When you first look at a picture of Messier 55, it just seems like another beautiful fuzzy ball of stars. But if you look a little closer, and I mean really look, you find it's this dynamic spinning system, and it's full of these stellar oddities that actually hold clues to the age of the universe itself.
So let's set the scene. Out in the constellation Sagittarius, we've got Messier 55, or M55 for short. Think of it as this huge ancient city of stars. We're talking about 100,000 stars all held together by gravity, just floating in space more than 17,000 light-years away from us. For a long, long time, we just saw it as that, a simple round clump of really, really old stars.
But yeah, that simple picture, it's not the whole story, not even close. Thanks to some absolutely incredible new technology and some really meticulous research, astronomers have found that M55 is hiding some pretty profound secrets about how these ancient star systems actually live, breathe, and evolve.
All right, so let's dive into the first big surprise. It turns out this giant ball of stars isn't just sitting there. No way. It's actually spinning.
Now, you gotta understand, the classic textbook idea of a globular cluster was, well, perfect random chaos. The thinking was that all the stars inside were orbiting the center in every possible direction, up, down, sideways, you name it. There was no organized motion. And that randomness is what everyone thought gave them their signature round or globular shape.
And that was the story for centuries, until the Gaia Space Observatory came along. Gaia's whole job is to build this ridiculously precise 3D map of our galaxy. And by tracking the tiny movements of thousands of individual stars in M55, it saw something nobody had ever been able to see before.
So what did Gaia find? It found the entire cluster is rotating. All those stars are moving in an organized way at about 1 kilometer per second. Now I know what you're thinking. 1 kilometer per second? My car goes faster than that. But for an object with a mass of 100,000 suns, that's a huge coordinated movement. It's like a ghost of the spin it was born with billions of years ago.
So, wait a minute. If it's spinning, shouldn't it be flattened out like a pancake or something? Well, not quite. The random, chaotic motions of the stars are still zipping around about 3 or 4 times faster than this gentle rotation. And since that random motion is still the boss, the cluster stays mostly spherical. It's a super subtle spin, but finding it completely changed how we see these things.
And believe it or not, the spinning is just the first surprise. The story gets even weirder when we look past the cluster as a whole and zoom in on some of the, well, bizarre stars living inside it.
First up on our list of oddballs, we have the blue stragglers. Now in a cluster where every star should be ancient and reddish, these things just pop out because they look way too young and blue. They're like cosmic rebels, and we think they form when 2 old stars either crash and merge together, or one literally siphons gas from its partner, giving itself a cosmic facelift.
Now, M55 is just teeming with these blue stragglers, but what's really remarkable is how they're behaving. A recent survey found that a whopping 47% of them are spinning incredibly fast, and that's a way higher number than you find in other, more crowded, denser clusters. Something special is definitely going on here.
And that something special is M55's neighborhood. It's all about the environment. This chart basically shows you the percentage of these fast-spinning blue stragglers compared to how dense different clusters are. And M55, right here in blue, is the clear winner. It's the king of fast rotators because it's the least dense. Its low density means there are fewer violent collisions to slow these stars down after they're born.
But the plot thickens. M55 also hosts another kind of stellar weirdo, the super-rare dwarf carbon star.
So what makes these stars so weird? Well, their atmospheres are just loaded with carbon. But here's the thing, it's not carbon they made themselves. It was basically gifted, or you could say polluted onto them by a companion star that was dying. That partner puffed up, transferred a bunch of its carbon-rich guts over, and then retired as a tiny white dwarf.
So you see the pattern here, right? Both the blue stragglers and these carbon stars are born from 2 stars interacting. And as this quote from the research paper points out, M55's low-density environment is the key. It's just a calmer place, where these fragile pairs can survive for billions of years without getting ripped apart like they would in a denser, more chaotic cluster.
Okay, so this preservation of star pairs isn't just for creating a cool stellar zoo. It actually turns M55 into this one-of-a-kind laboratory for answering one of the biggest questions there is. How old is the universe?
The perfect tool for this is a special system called an eclipsing binary. These are star pairs whose orbits are aligned perfectly with us here on Earth. So as they circle each other, one star passes in front of the other, blocking its light and causing the brightness to dip. By studying those dips, astronomers can measure the star's properties, like their exact mass and size, with unbelievable precision.
So the process is amazing. It goes from the huge to the tiny. First, astronomers survey the entire cluster, looking for interesting targets, like these blue stragglers. Then they zoom way in on the perfect candidate, in this case an eclipsing binary they named V54. And they do these incredibly detailed measurements, like tracking the exact speed of each star as it orbits.
It's a beautifully simple idea, really. First, you find one of these pristine eclipsing binaries that's managed to survive in M55's calm neighborhood. Second, you use its eclipses to pin down the exact mass and size of the two stars. And finally, you take those real-world numbers and you compare them to our best computer models of how stars are supposed to age. There's only one specific age where the models perfectly match the reality.
And the age they came up with is just staggering. Somewhere between 13.3 and 14.7 billion years old. That makes M55 one of the oldest things we've ever found. It's a genuine relic from the dawn of the universe, born just a few 100 million years after the Big Bang itself.
Okay, so let's bring this all together. We've seen a spinning cluster, we've seen weird stars, we've seen a cosmic clock, and it turns out they all point back to one single unifying idea. What is the secret ingredient that makes this seemingly ordinary-looking ball of stars into such an extraordinary scientific treasure?
The secret is its low density. That one single property explains everything we've seen. It's calm enough to let those fragile binary star systems survive for eons. That survival is what allows for the creation of exotic stars like the fast-spinning blue stragglers and those carbon stars. The lack of chaos also helps preserve that faint, ancient spin of the whole cluster. And most importantly, it protects the pristine eclipsing binaries that we can use as our most precise cosmic clocks.
So the next time you see a picture of a globular cluster, remember M55. It's so much more than a pretty, static snapshot of the past. It's a living, breathing, dynamic laboratory, quietly holding on to the clues we need to piece together the history of our entire universe.
It really makes you wonder, right? If a single, simple star cluster can hold all of this, what other profound secrets are hiding out there in the quietest corners of our universe, just waiting for us to find them?